section, so please try to work your way in. For those of you in the other, actually for both classrooms, if you have your clicker yet, please get it set up. Here's the basic sets of instructions for how to log in. If you're in the large classroom, you should be signing in to channel 65, and if you are remote in the other classroom, please go on to channel 51. And so you just hit this little channel button on your, well, you can read the instructions, and type in the number and then hit enter afterwards, and you should be all set. If you don't have your clicker today, don't freak out. We're just doing a test run today. It'll start counting towards grades next Wednesday when we get back from the holiday. Okay? And if we have problems with the clicker, the other room is more vulnerable to those than this room. If we do have problems, don't worry about it because this is just a test run, so we'll play it. But we have a guest speaker just to give a brief announcement before class starts.
So I'm going to try and not use... G'day guys, greetings from Australia. My name's Chelly from International Student Volunteers in Australia. I want to tell you about an incredible opportunity this summer if you've ever had the desire to travel a place like Australia, Africa, South America or Thailand. We're going to be selecting about 50 students from the University of Nevada to represent America in a special student volunteer work program this summer. Guys, the first 2 weeks is a volunteer work program. We have one of two choices. You can choose to work in social community development, working with underprivileged children and families in countries like Thailand, South Africa, Costa Rica and Dominican Republic. We do things like build houses for children, build schools for children, and do lots of other great things where you could even be staying with a local host family. Or you could be doing your work in conservation, working in environmental areas like rainforest regeneration or endangered species management with dolphins, elephants and cheetahs in countries such as Australia, South Africa and Costa Rica. During the second 2 weeks, you'll travel extensively in your host country, meeting the local people while exploring various ecosystems. You also get to participate in exciting adventure activities like whitewater rafting in Costa Rica, jungle trekking in Thailand, scuba diving in the Great Barrier Reef, or wildlife safaris in Africa. Guys, this program is awesome. ISV was recently selected as one of the top 10 volunteer programs in the world, and many students raise the cost of their program through sponsorship donation from the community. So, if this sounds interesting to you, then I'm going to pass around this sheet of paper and ask you to please print your name and email address clearly so I can send you an email with more information. Then rip a flyer off the back because it will tell you about our website, but it will also tell you about the information meeting we'll be holding on campus tomorrow in the Student Union, room 422, every hour on the hour, 9, 10, 11, 12, 1, 2, 3, 4, and 5, where you can meet students from the University of Nevada who participated last year. Guys, it's an incredible opportunity to travel with purpose this summer, and hopefully I get to see all of you tomorrow in the meeting on Thursday. Thank you so much, Professor, and I'll see you at the meeting on Thursday.
Wow. Okay. Sorry if I'm not quite so energetic. Okay, so if you haven't gotten a bunch of emails from us by now, then something's wrong. Check your spam folder. If that's not the problem, then please make sure you send either myself or Dr. Volstead an email so that we can try to work out the problem, whatever it might be. Oh, wait, let me hit the light level here. Is that better? Did that make a difference? Can you see it any better now, or was it not so bad in the first place? Wasn't so bad? Okay, I'm going to try leaving it on today because I was told that on video, everything up here, like me, looks pretty dark. So let me try leaving them on. As long as you guys can still see, we'll give that a shot. Too much? Better with them off? All right, we'll go with the other way. All right. For those of you who don't know how to set your whitelists in your spam folders, like if our emails, you find them in the spam folder, we have some instructions here. You can check these out in the PowerPoint slides online. You don't have to write it down if you don't want. You can go download it from the website. And there's some instructions you can find online about how to use this feature of most popular web browsers. So do that if you're having trouble getting our emails. It's quite likely that unless you put ENGR100 at the top of your subject line, your emails might not get seen by either myself or Dr. Volstead quickly. So we're doing our best to try to respond to our emails multiple times a day, but it really helps if you put ENGR100 at the front of the subject line. We get just as much spam as you guys do, so we'll see it very quickly if you do that. Okay, so last class we talked a little bit about being an engineering student. We're going to continue that today. We'll get a little bit more into the teamwork topic. Actually, those of you who have already had your skills lab this week have seen some of the teamwork topic stuff. We're going to continue with that because hopefully you're going to have your teams made by this weekend. Unless you have a Thursday or Friday lab, then you'll have your teams made probably Monday or Tuesday of next week. In short, we're giving you 3 days to respond to the CATME survey after your skills lab, and then we're going to make the teams. If you haven't responded, we're going to put you on a team full of other people who can't follow instructions. So think about it. All right? So please do your CATME surveys. Hovercraft project. We're going to really spend a lot of time on the hovercraft project discussion in next Wednesday's lecture. Remember, next Monday is a holiday. So the next lecture, we're going to talk about the hovercraft project. That's where we'll go over the rules. They can be a bit complicated, but they're that way on purpose because the real world is never quite so simple. At least that's what the faculty are sticking to as our excuse. They're a bit complicated. We want you to read them carefully. One of the things that you have to learn how to do is follow instructions, read instructions. Because in the real world, that's going to translate to reading specifications, understanding contracts, and things like that. Okay, so also, a new announcement. We videotaped the lecture on Monday. If you weren't there, you can check it out online. You go to week 1 and then lecture materials. There should be a link that will bring you over to the YouTube. We're going to try to do this for every lecture. So if you miss a lecture or if you want to remind yourself about something I said and you don't want to have to ask other people, whatever, you can go back and check out the YouTube video online. If it looks like people are actually using this, then we'll keep on doing it. It takes like a couple hours to get it up, processed, and then upload it onto YouTube. We're only going to do it if we find people are actually using it. So it's an experiment for now. Okay, so today's general topics, being an engineering student, teamwork, and the class project. First of all, how many of you remembered our advice? Did you review Monday's lecture for about 15 minutes, maybe more? All right, well, here's your chance to give me an answer. All right, first clicker question. So over in the remote classroom, if you can get your clickers going as well, how much time did you spend reviewing the notes or the lecture, or did you even watch the video? I watched it like 4 or 5 times. It was that good. Oh yeah, I have to do something here. Never mind. I got to follow my own training, right? Okay. Okay, now you have 30 seconds. Let me move this out of the way. Give me 1 second. Okay, I'll give you a few extra seconds. All right? Pressure's building. Now remember, if you don't have your clicker, don't freak out. But when we start doing this in class next time, it'll count. Okay, so let's see how we did. 36% of you didn't get off to a very good start. All right, 49% of you have superior study skills, or the lecture was simple. I'm not sure what it was. Only 16% of you followed the instructions. To be honest with you, I kind of expected this. But this is a habit, as I mentioned last class, you should get into for all your classes. Review them at night. It'll help you retain the stuff a whole lot better. Especially when you get into more complicated topics, which last week, frankly, really wasn't. Okay, we'll give the other room a second to get caught up here. That's the bad thing. I don't know whether they're actually caught up with us in the other room, so we'll improvise here. Okay, so our little task list. I'm not going to really be spending too much time at the beginning of every class reminding you of everything you have to do, but you have a lot of stuff you have to do. Check the website. Your to-do list that comes up in Web Campus will list all of these along with their due dates, and it's your responsibility to get them done. All right? Right now, some obvious stuff like getting your email sorted out, but you have quizzes. You have an online syllabus quiz. You have a reading assignment and a quiz to go with that. You have your student contract electronic certification. You've got to get your electronic book paid for. That's about $25 for that. There are a lot of questions like, well, what if I don't pay for it? you can still download it. It's right there on this, right below the link on the front page of where to get it. You can click on it and you'll get the PDF. You've got the book and you haven't paid for it yet, right? If you don't pay for it by the drop date of the class, you'll be dropped. Or at the very least, you won't get a grade. You'll go through the whole semester and you won't get a grade. All right, so 25 bucks. There's a whole bunch of complex reasons for why we do it this way. The bottom line is this was a way for us to offer the book for so cheap. Essentially, the publisher just says in October, how many people are in your class? And then we say 490 or whatever. And they say, okay, you owe us 490 times, I think it's $21 we owe them or something like that, or $25. Fairly straightforward, but I don't know, how much is your chemistry textbook this semester? $200, all right? So if you're going to complain about the 25 bucks, I really hope you're complaining about chemistry first, okay? So anyway, that's the reason. We wanted to make the cost of this class as low as possible. A few other students asked about, the other things you have to get for the class. And the other things basically mean your hovercraft parts. Your hovercraft, we'll talk about the rules next class. You're going to divide the cost of your hovercraft among your entire team. It'll probably come out to be between $50 and $75 for the hovercraft, depending on how many teammates you have. Right? So when you add it together, the cost for this class is going to be less than $100, which is half the cost of your chemistry class, and hopefully twice the fun. Right? All right. I'll let you pay attention to the to-do list on Web Campus. That's really the one that matters. Back to the how to be a good student stuff. We could give you all sorts of anecdotal experiences of working with students and being able to predict which ones are going to do well and which ones don't do so well. In short, the most successful ones are the ones who, whenever they encounter trouble, they're the ones that look for help. And that can mean go to your TA, go to the graders, go to your friends. It especially means going to the instructors. Some instructors might scare you. They don't want to do that. Sometimes we just do that by mistake. Don't get put off by that. All instructors have a desire to help out the students, and we don't always see which ones need the most help and proactively go to the students and ask them to come and see us. Right? You have to be partially responsible for your own education in that respect, where if you find that you're getting behind, don't be embarrassed and say that, and think that, oh, I'm behind, I screwed up on the last exam, I don't want to go to the TA or the instructor, they're going to be all mad at me. No, all right? That's the time when you do have to go to us and come and see us. Getting help when you need it is a sign of people who are, well, that are serious about their education. So do it, and that applies to the 4.0 students. The students that don't do well in a class like this, I mean, to be honest with you, if you're going to get a D or an F in this class, I have to congratulate you for trying really hard. All right? This is not a difficult class to get a passing grade in, frankly. Okay? Do the work, put an effort into it, show up, all the real minimal things, and you should be able to end up with a C. It's when you slack off, when you get behind, when you're too shy to look for help, those are when you're most likely going to run into trouble. We don't give out a whole lot of D's and F's, but I promise you those who get them in this course earn them by essentially not trying. Okay. So, little adage, it's got a lot of truth to it. Look at this. Different perspectives on education. I will take some responsibility, that's me, right? But you guys have to take some responsibility also. Okay. All right, getting involved. When you're just starting out as a freshman, I remember back when I was a freshman, you're all excited about a new profession, a new program that you're studying. You will be inundated with all sorts of people coming to you advertising their organization. Some of them will be quite energetic and from Australia, and others will be introverted engineers who have to speak up because you can't hear them. Well, you're going to get lots of opportunities. We're going to invite lots of these organizations here to talk with you before class, to tell you about the Society for Mechanical Engineering, or the ASME, American Society for Mechanical Engineering, electrical, computer science, civil. We're going to have them all come in and give brief talks to tell you about what they do. And there's a lot of activities to get involved with. I highly encourage that you do this. And get involved now, because it's a lot harder to get involved later on, not because they don't want you, but because you're going to feel inundated by all the stuff you have on your schedule. So do it now while you have free time. In a couple of weeks, making those connections will be a little tough. All right? So getting involved in your profession, in your studies, there's a lot of different points of view on this thing. It might just mean spending a lot of time preparing and doing your classwork. That's kind of a no-brainer. Spending time here on campus. This is especially true if you're a commuter. Do what you can to study on campus, form study groups. get involved with organizations and things like that. These are going to be good ways to become part of the broader opportunities that campus can offer, not just for engineering, but for everything. College is a pretty heady time in everyone's life, provided you take these opportunities. That includes everything from academic things to partying and having fun. All right? Not too much of that, right? Okay. Interaction with faculty, we try to provide opportunities for this. Last year I would have been advertising a barbecue, but it hasn't been scheduled yet this year, so I can't say that, where the faculty basically feed you ice cream and hot dogs and things like that. Right. And then finally, interaction with your peers, with the other students. All of these are ways to get involved with what you're doing. Hopefully this stuff is fairly common sense, but I'm going to say it anyway. Engineers succeed by learning and studying in groups. These groups usually surround people in your same class, but they might be the people that are on your team in this course that maybe they're not even in your same section of physics next semester or chemistry or calc or something like that. But you got to know them pretty well this semester. Keep meeting with them, study with them. It's great to be able to bounce ideas off of them, brainstorm for things. Working with other people is not the same thing as copying their homework assignments. I think that should be pretty obvious, but you can learn a lot from each other. Right? You can both do your own homework together. Photocopy each other's work and hand them both in, you're going to get nailed for it. If you work it out yourself, put it in your own words, use your own reasoning, you'll be just fine. And that actually helps with the learning process. We do this in engineering because this is what the real world is like. You're not going to work by yourself in the real world. You're going to work on teams, not only of your own disciplines, but of all sorts of disciplines. And some of them won't even be engineers. So you do have to know how to talk to and communicate with people who don't know the lingo about your topic area, about your expertise. Finally, to sort of reiterate the background stuff here, I said this last class and I'll do it again. I recommend, it's almost required to succeed, looking at being an engineering student, being a student, frankly, as your full-time job. If you do this, if you put an honest 40 hours a week into being a student, you'll succeed, and unless you have other issues going on. You'll be able to get the work done, and you'll be able to get grades that'll see you through to the end. If you don't, you'll just be a minion, as I was saying last class. Okay. All right. What are characteristics of an engineer? We could make a whole bunch of different lists for this, right? But I want to look at this from the point of view of what the reputation of engineers are, right? The first thing that I'll say, and you can debate over these things with me, that engineers typically say, oh, they're smart, they study hard, they take lots of classes and things like that. But what else is there to being an engineer? Well, I would propose that typical engineers have a passion, some might say an obsession with things. Right? So what do we call the overlapping area in between these? An intelligent person who's obsessed. A geek. All right? So now we're sort of talking about the stereotypes of engineering. You as an engineer are going to be living with these. Roll with the punches, laugh along with them, right? Do whatever it takes. There's some truth to all this, but we can revel in the truth to it, and we can buck the trend and break down the perceptions wherever we can. But this probably isn't it. What else is typical of an engineer? Well, right? Again, these are stereotypes. The social ineptitude, right? And now, of course, you can start, these are like remember Venn diagrams from math? At least I do. You can look at the overlap areas between all of these, okay? So, if you match all of these, you can call yourself a proud card-carrying nerd, right? I probably consider myself a mix between intelligent and obsessed. I know I'm not socially inept. I have lots of friends in real life that are not on, not on Facebook. But you can figure out where you fit into this little scheme and decide how you're going to break down the barriers and portray yourself, right? But you're going to see these things out in the real world. So, where do you fit into this? This is your next clicker question. I rephrased them a little bit. Let me get the clickers started here. All right, I'll give you a little bit more time here. Try to be honest. Don't give the answer that you think we want to see. This question has no wrong answer. All right, quick, hurry up. All right. So there you go. Most people don't think that they fit into the stereotype, right? Whoever thinks they're part of the stereotype, right? After a year or two, ask your friends to answer this question about you and see what they say. So, all right. 25% of us think that their technical skills are their strengths, and that's probably not a bad thing for engineering. I'm a little disappointed more of you don't feel confident with your communication skills. That's not uncommon to be, I say disappointed. I say I'm not surprised, really. That's something that we try to work on here at UNR. You're going to have lots of opportunities to work on your public speaking skills. And this next topic that we're going to get into in a second is about teamwork. And one of the key things to teamwork is learning how to communicate with your teammates. And this is where you can start working on those social skills, right? All right. So let's... go all the way over here. So teamwork obviously involves the ability to do all that technical stuff, but involves working in the framework of a team, being organized about what you're doing, and from your employer's point of view, that means keeping things on time and on schedule. And the only way you can really have a hope of doing this is by mastering all these technical things, because that's where you figure out what you have to put on your planning list, obviously, right? And then finally, maintaining the good communication in all aspects. This includes everything from your writing skills. Yes, you have to write as an engineer, probably a lot more than you realized. That's a typical misconception. Public speaking to groups, public speaking to people who pay your paycheck, to your customers, all these kinds of, in other words, high-stress public speaking is going to be parts of your career. And we're going to give you lots of high-stress public speaking opportunities because your grades are based on it, right? So that's why we call it high stress. And then your interpersonal skills. The teams that are going to work best on these hovercraft projects are going to be the ones that work well together. And that doesn't mean are the best buddies of each other. That means those who each bring something to the table. They can share ideas. When they say something stupid, the other people aren't going to jump down their throats. They're going to step back and say, well, maybe they meant it this way, or whatever. These are what our good interpersonal skills are all about. Being able to figure out what they meant to say is sometimes just as important as understanding what they did say. Okay, so we'll work on those types of things, and you'll have lots of opportunities to do this on a weekly basis with your teammates. So this is an important skill that you're going to have to master. We're starting this out using our CATME system. So please raise your hand if you've done your CATME quiz. All right, that's good. Dr. Volstead told me that Section 6 and Section 20, 100% of you have already done it. She's really happy. You're her favorite sections already. So congratulations if you're in those sections. If you haven't done it, I've been getting a lot of emails today for people who are having trouble. If you haven't heard back from me, send me an email if you're still having trouble getting into CATME. You need to get that taken care of. This CATME stuff, as I said last class, will help us. It gives us an aid to help assign teams that make the most sense possible. I mean, sometimes you can't help but mixing people whose schedules aren't perfectly aligned. But that's what we're trying to do. Get schedules to match, maybe what you think your strengths are, your, I don't want to say interests so much, but we're doing our best to mix and match teams. Now, one of the issues on these things is gender. We try to make an issue, not an issue, well, I guess we do make it an issue. We try to take account of gender and things like that because there's lots of research out there. Every year, like, for example, there'll be a team of 4 and they're all girls, and the rest of the class are all guys. And people come to us and say, well, how's that diverse? All right? It's a good point, good question. There's a lot of research out there that suggests that things like ethnicity, race, gender, all of these types of things are better to mix, but we found in the disciplines of engineering where you're working on team projects that if you put people into a group that are similar to each other, they stand a much better chance of everybody learning all of the aspects of the project. There are lots of stereotypes that everybody brings to the table. We all have baggage, and we do things that we don't always know we're doing. We have intentionally chosen to try to group people into teams that we think where everyone on the team will be able to learn all aspects of being on the team. And you don't have one person who's pigeonholed into making photocopies and taking notes, or they have to do all the writing, or they have to run all the meetings, per se. All right, so we're doing our best to use this software, and it really is based on actual psychology research when it comes to working on a project team. Okay, so for those of you who noticed that that's how some of the teams get put together, it wasn't at random, and we recognize it flies in the face of diversity, but there is a more fundamental objective underneath it all. Okay. If you have issues with that, you can come and talk with either Dr. Volstead or myself. Okay, this working on a team is going to start next week. As I mentioned, our teams, the CATME stuff is going to be run this weekend, maybe early next week, depending on what section you're in. And we're going to make you guys aware of which team you're on through CATME itself. All right? Well, you'll find out your next skills lab at the latest. But if you want to know sooner than that, you can log on to CATME, and you'll actually be able to see which team you're assigned to. Starting next week, you have to meet with your team. There are going to be new assignments posted where you have to meet with your team and do a bunch of stuff. Okay? The first thing that you as a team has to do is put together what we're calling a team charter. And the team charter is essentially, it's like a contract in business. It's where you and your teammates come to a common understanding about what you're all doing. Right? Hopefully it's going to be in the context of the class, so you're going to be working on the class. But when I say what you're doing, I really mean more of the details, so that everyone understands how to reach each other. All right? So after this first meeting, you as a team, you should be exchanging contact info. You should be writing it down on a sheet. We're going to actually have you put that information in your journals. I'll get to that in a little bit. Your team should have some goals, a mission statement of sorts, something along the lines of kick butt in the hovercraft contest or something like that, phrased much more professionally than that, though. Okay? It should look an awful lot like a contract. You are going to have to work with contracts and memorandums of understanding and things like that throughout the rest of your life as an engineer. Start getting used to it. They're binding, frankly. In the real world, they're legally binding. If you don't clearly understand what your customer is expecting of you, they might be quite irate with you when you hand them the project or the product or the prototype. Okay? So being able to work with these things, and people learn the hard way how to write a good contract. One that, you wrote a contract and the customer's still angry with you, you learn a lesson. Well, we probably should have covered that in the contract. Like what happens with cost overruns, who pays for them, things like that. If you don't have these types of things understood, you're going to have lots of problems. And working as a team, it's best to put it all on the table up front. Do not go into these team meetings with an aggressive negotiating approach, but neither should you go into them with the sense of laissez-faire, oh, hey, I'll see you next week, dude, and we'll just let it go, and somebody will do the work along the way. We'll just figure it out as we go. Right? You have to be a little bit more clear about that. We're actually going to insist on it when you do your team charter. So you should talk about what the roles of the people on the team are. If they're shared roles, like, for example, I'll take care of doing the draft of our first concept design report, you will proofread it, and then for the next concept design report or for the final report, we'll have these other two people do the primary writing and the drafting. Or maybe that doesn't work well. That's probably not a fair balance of the work. These three people will share, each will write different sections, or one person will do the programming, or one person will keep track of the budget. One person's job will be to organize the team meetings and make sure everybody gets the emails and responds yes or no, whatever. You as a team have to decide how you want to get organized in this regard. And try to get a little bit particular about this. Get into some of the details, because the details are going to be what help you guys get along in the end. If everybody understands what's expected, arguments get minimized later on. Okay? But obviously, arguments aren't good. Try to develop good relationships. Define procedures, mission statements, goals, things like that. You are actually going to have to keep a team journal for this course. Every week, you're going to submit it in your skills labs. This charter should be right up front in your team journal. Your contact information, that's also how we can contact you when we're grading these things. But every week, you're going to be adding another section, week 1, week 2, week 3. You'll keep notes of your team meeting. They're not going to be volumes of notes. It'll probably be like one page of outlining, summarizing the things that you talked about and what things you agreed that you would have done for the next meeting. And then for the next meeting, the first thing of your order of business is going to be to look at what you promised you'd do to yourselves last week. And then you'll say, oh my God, we only did one of these 6 things. You as a team will be reminded of all the stuff that you're behind on. Okay? Hopefully it won't be that bad, but that's one of the points behind this. All right, I'll talk about this a little bit more later on. We're going to recommend that you use a template for your contract. That way you're assured of putting in stuff for all the things we want. We are giving you the Word document. All you have to do is open it up and go to the red text and put in your own language, the stuff that your own team agrees to do. Okay, so this way you'll be handing in a fairly common format for us to take a look at and give you feedback on. Okay, so you don't have to compose it completely from scratch without having a clue about what you're doing. We give you guidelines. edit what we're giving you. Your team should get into the habit of scheduling regular meeting times. As I mentioned last class, every Wednesday on your schedule there is a meeting time between 5 and 6 o'clock, right now. Okay? This is reserved in your schedule so that everybody can meet. You don't have another class. You've got this class, but you don't have to go anywhere. We recommend that you get together as a team. Obviously, today you don't know who your teammates are, so you don't have to do that. But next week, you have to get together as a team to figure out when you are going to meet. And if you do it in the 5 to 6 o'clock on Wednesday time frame, by all means. Later in the semester, if you're only spending 1 hour a week with your teammates, that's not going to work. But to get things started, you won't need that much time. Contact lists. You as a team at your first meeting should select a leader. And this is not the boss. Don't get me wrong here. This is just somebody who is, I recommend, someone who's fairly well organized, who can stay on top of keeping abreast of what assignments are due as a team and things like that. If you prefer, you can rotate the team leadership role each month. If you have 4 or 5 people on your team, September, all right, you'll do it. October, next person does it. I don't know how you want to do it, but there should be somebody who is responsible for representing your team in class to your teaching assistants in Skills Lab. Please do that. Plan out your time. A major step of planning your hovercraft design project is going to be telling us the schedule by which you will do it. And we'll be showing you how to think about these things, how to plan for these things, and we'll be training you on how to use charting software, Gantt charts. We'll be posting a video in Web Campus, and we'll also be talking about it quite a bit in the Skills Labs. And then finally, an important thing for your team to understand is how you're going to work with your budget. Right? Your hovercrafts, we're talking $300 here. If everybody agrees that one person is going to pay for everything, but they get to walk away with a hovercraft at the end of the semester, all right, your team, now granted, some of the parts on that hovercraft you have to give back to us because you're renting them from us, but you can work it out as a team. Most teams, 99% of them, just divide it evenly among everybody. It's going to be divided evenly. On day one, everybody has to put $50 into the pool, and a certain person will be the treasurer. They hold the money, and they're the one who actually calls in the orders to the electronics company, or who goes to Home Depot to buy, or who gives someone money goes to Home Depot, and that person has to bring back a receipt to prove what they said. You don't have to prove it only to your teammates. You've got to prove it to us. We're going to ask for your receipts for these things. All right? But as a team, at the least, you have to figure out how you're going to figure out the logistics of it all. Some teams say, all right, today we have to go buy nuts and bolts. Everybody give me $1.25. All right? You might do it that way, or you might just make a big pool of money that you spend down whenever you need to, and as needed, people add more money in as the semester goes. It's not generally all that hard to come in under budget in this class. $300 is typically the upper end of what you have to spend. It's roughly $50 for the things you'll rent from us, and the rest of the parts, the expensive things, are probably going to be your batteries. That's really the most expensive part. You can usually get the batteries for less than $100. Depends on how fancy, your batteries are. You can probably get your batteries for $25. You'll need a charger probably. You have to get that in there. And then the styrofoam or cardboard or whatever you buy, that's measured in less than $10 increments. So $300 is quite a bit for the project here. If everybody just agrees that they'll divide it evenly along the way, and if it comes out to be $150 in the end, each of you pay 1/4 of $150. Right? So just make sure you understand and that your teammates understand all these things. We're going to be asking you to document this, as I said a second ago, with weekly journals. Right? The idea behind the journal is sort of like a diary, but it's obviously more technical than that. We have a journal form that we're going to recommend you use. Lots of instructions. If you've already done the reading assignment for the first week, you'll see some of the stuff about working as a team and keeping good notes as a team. You're going to keep all your receipts in here. You'll put your design reports in here. You'll keep all your weekly meeting notes. Anything related to your teamwork to your project work as a team will go into your journal. And we're going to take a quick look at it every week just to make sure that you're doing it the right way, so to speak. And then we'll put it back in, we have these cubby holes in the lab. You might have walked by them on your way to your skills lab. Ideally, we're going to try to have those graded within 24 hours. Ultimately, these journals are going to add up to 5% of your grade. All right, so please try to stay on top of those. The journals really are for you. That's the idea behind these things. all scientists and engineers out in the practicing world, they keep notes. And when you're on the job for 5 years, very often someone's going to say, this thing broke. Where did you buy that part in the first place? And you're going to be, well, that was 5 years ago. I don't know. Go back and look in your notes. Look in your journal. That's where that kind of a thing will be there. Trust me, this happens all the time. I go back to my old notes on a regular basis. And it's good if all of your notes are in one place, so a journal is a good idea. If you're the type who just writes things on individual scraps of paper, if you can transcribe those into a journal, that's even better. Nowadays, there's lots of good electronic journal software, electronic note-taking software that people use. That's up to you, but for this class, we want 3-ring binders, 1.5 inch, don't get like these 6-inch thick binders. They won't fit in your mailbox when we hand them back to you. 1.5 inch, 3-ring binders. We have about 100 of these binders left over from last year. So if you want a freebie on your way into Skills Lab next time, we have some tables set up right outside the glass windows of the Skills Lab with binders piled up. Just take one, all right? You can tape over or cross out last year's team number on it. You have to put your own team number on it. That's up to you. Some people put artwork and things like that. We don't grade that, but you can do that. So we are going to have you use a specialized journal entry form. Your team has to meet once a week, all right? There are administrative things you have to do in these meetings, but really it's about getting the real work done of your hovercraft project. It's got to be done every week. We're going to give you a form that gives you the basics, okay? And on that form are going to be essentially lines where every person on your team has to sign and say what percentage of the work this week they contributed to. So if you have a team where everybody is equally dividing the work this week, you put 20% everybody for 5 people. Right? If you are really busy for one of your exams in the 3rd week, you can just say, you know, I only worked 5% of the total team work this week because I had an exam. And then you should point out, partly for the benefit of your teammates, because trust me, they will notice if you're only working 5% of what everything's being done. You just say, we agreed as a team that I wouldn't do much this week. Next week, I'll be working extra, or something to that effect. And you can just say, for example, next week we have the project report due. I'm going to be the primary author of the project report. Everybody else will be able to slack off a little bit on account of me making up my time. So those types of things, and everyone will have to sign off on it. This really helps us, it helps you as a team keep everything out on the table so everyone's not disappointing each other in secrecy, and you are evaluated by your peers. We're going to do some of this with CATME surveys periodically throughout the semester also. It helps us identify teams that are working well and teams that might have issues that we have to work out. 99% of the class, frankly, evaluates themselves quite well. In fact, when we see problems with the CATME, it's usually because people don't give themselves enough credit. Right? Somebody who the rest of their team said, wow, they did everything, and they just said that they did the average amount of work. Right? We see that kind of comment far more often than we see this person's a slacker. If there is a slacker on your team, first of all, handle it as, this is your chance to work on your social skills, right? Handle it as delicately and as politely as possible. I recommend that you try to work these things out. Right? We are not letting you choose your own teams for a reason in this class. You don't get to do that in the real world. That's the reason, frankly. Right? You're put together in the real world on teams because of what you bring to the team, what your skills are, not because you like somebody. Okay? We're going to start that in this class. Hopefully they're going to become friends. We're not trying to say that getting along with people isn't a good thing by any stretch of the imagination, but that's not the primary thing we're aiming for. You'll work as a team. You'll evaluate each other as a team, both publicly so that the team knows, like when everyone has to sign these work divisions, and anonymously, not to us, but anonymous to your teammates when you do it through CATME. All right? So this is our way as the faculty get a chance to keep track of these things. Okay, so we already talked about most of that stuff. So your first meeting, just to reiterate here, get to know each other. Okay? This might be the first time in which you actually have a chance to chat with some of the people on your team. Put together your contact information, and don't just give it to one person, right? How's that helpful, right? Make copies for everybody on your team so everybody has everybody else's cell phone number, email address, things like that. You're going to use these things a lot throughout the semester. When someone shows up to the first checkpoint and one of your teammates isn't there, we're not going to grade it. If we don't see your whole team there, we're not going to grade it. So that's when you guys panic and say, where's Mike? I don't know, I have his cell phone number. Let's call him. You know, oh, he's still in chemistry. He'll be here in 10 minutes. All right? Those types of things. Gantt charts, establish your roles, plan out your calendar. You can't do this on day one necessarily, but you should have a little bit of an idea of the course schedule by looking at the syllabus. Figure out what your goals and objectives are. This team charter is going to be due in 2 weeks. It's not due next week. Don't freak out. It's going to be due essentially a week after you know who your teammates are. So you'll have a week to put this together. All right. Key thing, communication on your teams. Okay. If you get into problems with communication, try to work it out. But do not hesitate in seeking instructor assistance. We keep things confidential if you prefer it that way. We do the best, and we're pretty good at smoothing over egos. Somebody doesn't want to complain to the team because they don't want to get people angry with them. These are perfectly natural feelings or interpretations of the situation. In the real world, you're going to have to work on these. We're going to work with you to work on them as you get used to them. We'll give you ideas for how you can approach your teammates without ruffling feathers, things like that. But don't let things fester. All right? Communication is important because if your team becomes dysfunctional, remember, the things you do as a team are worth 60% of this course's grade. And if your team is dysfunctional, that's going to be a problem. We've got lots of ways to picking out who the slackers are on the teams. We do have some people who get Fs in this class, and they earn them, but they don't skate through. We have lots of mechanisms for us to figure out who these are. But in the meanwhile, we don't want them to make your life miserable for the rest of the team. So work with us, and we'll try to work with you as best we can to solve these problems. Okay, so, boy, these are a bit repetitive, I'm realizing. So do your cat me. All right, design. We have about 10 minutes left here. We talked a little bit about this last class, and we'll be getting into the design actual rules for the competition next week. Design really is the essence of engineering. It involves a very careful and intentional process of applying the technical stuff that we know and the non-technical stuff to deliver a product that meets a certain objective or a certain deliverable within certain constraints that the customer is giving to you, right? It is almost always a team-based activity, but the bottom line of design in reality is that you have 3 things that you have to factor in. If you go to your customer, they're going to tell you everything, and your response to what they're going to say, I want everything, and I want it to cost nothing, and I want it now. All right? You as the engineer have to use your social skills to convince them that I can give you 2 of these 3, usually. Okay? And if you want something fast and good, it's going to cost you. Right? If cost is a major factor and you want it to be good, it might take some time. It might be impossible for that matter. Right? You get the idea. Pick 2 of these 3. Your instructors in engineering are going to be insisting that you push the limits and give you all 3 of these in as many situations as possible. And in that case, the cost might not be dollars. It might be something else in there, like your sanity or how much sweat you put into something. But part of your skills, I mean, don't try to talk an instructor into thinking that their assignments are too hard. That's not going to work. It might work with a few instructors, but generally, that's the way it works in the real world. So in a nutshell, the design process is an iterative one. All right? We don't just wing it when we come to the design process. You have to identify what the customer wants, what your problem is, where it's going to be used, what the specific, what it's got to do, and what the constraints are behind the process. And once you've done that, and really only once you've done that, once you know the rules, don't go home tonight and start working on the hovercrafts, because I haven't told you what the rules are, for example. Once you know the rules, you can actually proceed with coming up with ideas, brainstorming. We'll work with you through this throughout the semester. Don't just start building the very first idea that your team comes up with. Come up with 5 or 10 ideas, and then work through as a team. Talk about them. Put them into different categories. This one deals with jet engines. This one deals with batteries. This one involves hamsters turning a fan to get our hovercraft off the ground. Right? You can come up with a lot of ideas, and they're not all going to be equally good. Right? But don't flush them down the toilet because they sound hard or impossible at first. Talk about them with your teammates a little bit at first, because you might discover that what seemed like a really outlandish idea at first might become very doable if this little issue was dealt with, or if we just tweaked it a little bit. And you might not see it yourself, but your teammates do. This is an important part of the design process, the brainstorming phase. And it involves coming up with a lot of ideas, because when you have a lot of them, you can generally narrow them down and select a pretty good one that you want to proceed with. This is the way to efficiently use your time. Designing and building and testing things takes time and money. That's the expensive part. You want to do the best you can earlier on by coming up with a lot of ideas and then selecting the good ones. And then you're not done. This is an important one here. Notice this in capital letters, right? Testing is critical. If you show up to the first checkpoint, actually third checkpoint, with a hovercraft that you've never turned on, that's probably not a good idea. I think that's pretty obvious, right? Testing things is an important thing. Turning it on once and coming to us and saying, you know, you show up with your hovercraft where it has to hover in place for 2 minutes, I think is the rule for the first one, right? And it hovers and then flies off the table. And then you say to us, it worked fine in my dorm last night, right? We heard that one a few times, right? You tested it, but you didn't really test it. Test it in the environment it needs to be. Test it with the customers who are going to be using it. All these types of things. Testing it means as close to reality as you can get. Okay? And then after you've tested it, almost always you're going to discover you want to fix something. Maybe even restart everything all over. Maybe you have to go all the way back up here and brainstorm again. Maybe you don't. Maybe you just have to tweak little things and improve them. Okay? But it's an iterative process that you're going to go through a lot of times. And then once you've finalized it, out in the real world, you've got to do something with your product. You've got to go out and sell it. You've got to give it to your customer. You've got to communicate it, get the word out to whoever cares about what you've just done. In this class, this communication is going to take the form of oral presentations to your instructors, written reports. It's going to involve actual competitions where you show up and do it for your grade. This is where you disseminate the information. Out in the real world, they're much more down and dirty practical things like selling it to somebody, for example. And you'll get help from people who are good at selling. But as an engineer, you have to know that stuff. So just to reiterate, the design process is not a linear one. You're going to go through it over and over and over, hopefully not 1,000,000 times, but you're probably going to iterate, test, make improvements 2 or 3 times, maybe 5 or 10 times, all depending on how close you got that first time. But the idea is that an engineer will continue to work on a project until the deadline. In fact, the business community has a saying that if you want to end a project, shoot the engineer, because they're always going to be trying to make improvements right up to the last minute. I've had grad students at design competitions rewriting their source code 3 minutes before they're actually out on the floor competing, right? And they're grad students, so they've done this for years. It's inherent to the engineers. You can always make it better if you only had 5 more minutes. You're going to drive the business folks who are trying to meet with the customers, and they want to take your product to the trade show to show the rest of the world how great of a product you guys just made, and they don't want you, redesigning it in the car on the way there. Right? Okay, so this year's project, I'm running short on time here. This year's project is a hovercraft. I'm going to talk about this extensively next Wednesday, but in a nutshell, it's a hovercraft. It's going to be about 2 feet by 3 feet. It's not going to have to pick you up or a person up. You could probably make a small person-sized hovercraft that would lift you up using a leaf blower. A lot of people do this and they have fun and break their legs and stuff like that. It's got to be autonomous, not remote controlled. It's got to be powered by batteries and fuel cells. So we'll be teaching you about these things as we go forward. In the end, everyone's going to have a different design from each other, so we don't really have to worry too much about these things. We expect you to be creative. There's a lot of different ways to approach this. All right? Here's one example of one of the teams last year. They just made a circular deck. They had fans with little grills so you don't stick your fingers in a running fan and end up with a broken finger. Fairly small, it was probably about 2 feet in diameter. And that's really all it did. They had a mechanism to do their propulsion. We'll talk about that next week. And it worked pretty well. Okay? But remember, just to sort of finish up here, this class is not about hovercrafts. Right? This is about design. Okay? An introduction to design, introduction to being an engineering student. So I'm going to talk about all these touchy-feely stuff. But the bottom line is we're trying to prepare you to have an idea about why you're here and what you're doing. So that's it. We'll see you after the holiday. Next class.